Hello everyone. Today we are coming back again to my channel. We are coming up with the new topic, which is logarithmic functions. Okay, so this is the first lecture of the logarithmic functions. So let's move into the session here. First of all, we need to look at the what is a logarithmic function. Okay, so logarithm function is the inverse of an exponential function is called a logarithmic function. First of all, you should need to know what's the exponential function. Exponential function is look like this, y to the a to the power x. Okay, if you draw this exponential function, it will look like this. Okay, because in here we should need to know the thing here a greater than 1 also. Okay, so it will look like this is the exponential function. But here said that the inverse of an exponential function is called a logarithm function. Now you know this is the exponential function implementation. So you need to take the inverse of it. So that how do you get the inverse of the exponential function? You need to interchange the x and y value. So therefore inverse of this exponential function, you can write it down like this. You need to interchange x and y corresponding to the y. This is the logarithm function, logarithmic function implementation. Okay, so this is the first point that we need to understand. Okay, so let's move to second point. So as for the exponential function, we can take y equal a to the power x. We have already discussed this concept, and if we reflect its graph across the line y equal x, we get the graph of logarithm function. So this is very important. Now I have already told you, okay, this is the x, this is the y, and you will have the exponential function at the first. What is the preview of the exponential function? It is look like this. Okay, this is the exponential function, exponential one. And what is the how we can denote it? Y equal a to the power x. And there's another one, it's in the point. There's another function called y equal x. Y equal x means it look like this, y equal x. Okay, so it is said that if we reflect its graph across the line of y equal x, so that means if we reflect this graph, that means the exponential one, around the y equal x graph linear line. So what is the preview of this one? The preview of this one is look like this. Okay, so it look like this. So if we reflect this graph around this linear line, it look like this, and this line is called as y equal log a to the x. This is the logarithmic function. Logarithmic function. Okay, this is the next theory you need to learn. Okay, so that's up to the second point. Let's move to the third point. Okay, so the third point, it is say, so this is the logarithmic function can be displayed as x equal ay and y equal log a to the x. And so we have discussed both of the scenes. So as you can know, the exponential function you can write down y to the a to the power x, and if we take the inverse of this one, that means we need to interchange the x and y values. So therefore you can write it down x equal a to the y. So this is called as the logarithmic one. Or you can write down it the same one as y equal log base a to the x, and write it down in the clear manner. Y equal log a to the x, and we can write down like this as well. Okay, x equal a to the power y. This is the exponential form. This is the logarithmic form. Right? So you need to understand both the thing here, and in apart from that, here a greater than 1. Okay, otherwise you cannot apply this theories. So next move to the next concept. And here, if you got the logarithmic function, if you write down the logarithm function y equal log a to the power x, base a to the x, you can write down this same one, and that's you can say x equal to the a to the power y, a to the y. You need to keep remembering the way. You need to have a capability of converting logarithm into the exponential and exponential into the logarithm, both ways. Otherwise you cannot solve these particular problems. So in apart from that, here x is also greater than 0, because you need to remember inside of the logarithm cannot take any negative value. Okay, and a should also the greater than 1 here. These 2 points you need to remember. Okay, so next move into the next page to look at the concepts. So okay, now we are coming to the example number 1. The problem is said graph y equal log base pi to the x. Okay, I have already informed you that you should have a capability of converting logarithm into the exponential and any exponential function into logarithm. Okay, otherwise you cannot solve this problem. So how we now you will get the logarithm way. Now you have to convert into the exponential way. Exponential. Okay, how you convert that? You can convert it like this. X. This expansion came here. X equal to the pi to the power y. Okay, this is the exponential conversion. Okay, so then, but this is the function, you need to draw it down. Okay, now you have, this is the y equal x linear graph, and you will have this graph as well. What is this graph? X equal pi to the power y. You should need to draw this one, what corresponds to accurate data. But if you apply x equal 1, 2, 3, 4, 5, 6, but the thing is, if you try to draw this one, if you put 1 here, you will get, it's little bit difficult to find the y by using this method. So there, but if you can do another method, but if you find out the mirror part of the other way, it look like this. You can, the inverse one of this one, you can notify like this. Okay, inverse one, inverse function you can write it down like this. You need to interchange the x and y values, so you can write down y equal pi to the x, but this is it's the exponential function. This is the exponential function of this logarithm one. Okay, so now you can very easily find out the x and y values corresponding with the particular x value. Okay, now it's a little bit easier. So let's take the x and y value. Let's find out. I will take the -2, -1, 0, 1, 2, 0, 1, 2. If you if you substitute these x values to equation number 1, you will get you need to find out the y values. If it's a minus 2, you will get the 1 over 25. If it's a minus 1, you will get the 1 over pi. If the 0, you get the 1. If it's a 1, you get the 5. And if it's 2, you get 25 here. Okay, now here you can write down like this. For 0.01, here you will get the 0.2. Okay, so now you know this value according with this one, but you need to find it out actually this one. How you can find this one? You can find this one. You need to interchange the x and y value. Okay, here 1 over 0.04, 0.2, 1, 5, 25, and here is when it's 0.04, you will get the minus 2. So 0.2, you get the minus 1. 1, you get the 0, and 5, you get the 1, and 25, you get the 2. Okay, so now you can draw it down the particular graph actually. So in order to do that, you need to first of all erase some of this graph. Okay, now you can draw it down this graph very easily. Okay, here the x, here the y values, and when it's the 1, x value will be 1 like this, y value should be 0. Okay, here 1, and 5, it will be 1, and 25, it will be 2. You can see it will rise like exponential, right? So 1, 2, 3, 4, 5. When it's 5, it look like a 1. When it's 25, that means 5 and 25. Okay, you can do it like this. Okay, so it will go like this, and you know y equal x is look like this. This is the y equal x, and this is the graph they will look ask from us, and the exponential function look like this. Okay, exponential function look like this. When the x equals 0, it will also take in the y1 value, and when the x is 1, it will go up to the pi value, and x is 2 is going to 25, but purely symmetrical around the y equal x. Okay, so I think I have given you the brief introduction about the logarithm. So let's move to the other part as well. Now in this case, they will ask to convert to logarithmic equations. Before moving to the example, I have to tell you something. If you take the 64, okay, you can write down 64 in this way form, a to the power 2. So this is the exponential form. How you can convert into the logarithm form? That's the task. You can convert it to look like this. To find out, however, we need to write our log. So to find out the 8 here, because this is the base of the logarithm, and to find out the 64 here, 8 come to here, 64 come to here. So the power of this part, that's the answer. As for the another example, this is number 1 to 81, you can write down 9 square. So how you can write down? You have to put the log here, and what is the base? Base should be 9. This is the base. Here you can 9, and 81 come here, and what's the power part? Power is come here. That's the answer. Okay, this is how you need to know. Okay, so okay, but sometimes you will give the example like this. Now you will get the need to convert the logarithm into the exponential. How you can do that? That's the another question. Log 9 base 9 to 81. How you can convert it to? Okay, that's the another case. 81. Okay, this is the problem now you are facing. How you can convert this one into the exponential way? Okay, so but the answer will be what? Answer will be 2 here. Okay, so what is the meaning of this one? That's the very important thing. Okay, now this is the logarithm to convert to the exponential way. Okay, so you need to find out 9. If you consider the 9, if you raise the 9 base into somewhat value, you should need to get the 81 value. Okay, if you raise up the base of the 9, power of 9 to somewhat number, so it will get the 81. Okay, that is the exponential one. So what is the value here? 9. We can take 81 if you power of 9 to the 2. Okay, so that's how you will convert the logarithm into the exponential. Okay, so we need to find out, we need to take the another example. If you take the log base 2 to 4, what is the value? 2, right? So here also, if you take up the base 2 to the power somewhat number, it should be equal to the 4. So what is the value here? It will be 2. So that's how we need to convert logarithm into the exponential way. Okay, so I think you understood the concepts. So let's move into the examples. Okay, for the first one, now they ask in the convert these exponential function to logarithm equations. So first of all, they will given the example 8 equal to the power x. Okay, so how we convert this one to logarithms? Okay, you can convert direct to logarithm by looking at them. Log base 2 to the 8 came here equal to the x. Okay, I think you got it. Okay, so next move to the second one. Here the question is said as y to the minus 1 power. So you can, it's same as the previous one. Log, okay, y came here as a base, 4 came here, 4, what is the answer? Minus 1. Okay, so let's move to the third one. C equal a to the power b. Here log a come here as a base, c there, what is the answer? B power. Okay, let's move into the next session. Now you need to convert to exponential logarithm to the exponential function. Here the first one you will given as y equal log 3 to the 5. Here how you convert this logarithm to the exponential? You can write it like this, right? 5 equal 3 to y. This is the first way. Okay, so very simple. So let's move into the second part. Minus 2 equal log a to the 7. So this logarithm function you can convert to the exponential way like this. 7 equal to the a to the minus 2. Okay, this is the answer for the second example. Next, move to the third one. It's given as a equal log b to the power bs b to the d. You can write it down like this. D equal b to the power a. Okay. Okay, now we are coming to the final part of the session. It is said that the solve logarithmic equations. Okay. In the first one, it given as a minus 3 equal log 2 to the power x. This is the logarithm way. Now you need to convert this logarithm function into the exponential function. How you can convert it? Write it down like this. X equal 2 to the minus 3. So the answer will be 1 over 8. Right? So let's move to the other one. Here you will get the 2 equal log x to the 16. Right? Here you can write down this logarithm function. You need to convert this logarithm function into the exponential one. You can write it like this. 16 equal to x to the power 2. Okay. What is the x value here? X squared minus 16 equals 0. X squared minus 4 to the power 2 equals 0. X minus 4 here and x plus 4 here. So the answer will be x equal plus 4 or x equal minus 4. Okay, but in the logarithm base cannot be a negative value, so this is not the solution for this logarithm function. So the answer will be x equal 4. Okay, so let's move to the third question. Here they will ask the log 10 to the 1000, right? Okay, in order to find out, I will take this one as a y. So now you need to convert this logarithm to the exponential way. How we can write down? That's why I have this one equal to the y. Otherwise we cannot convert this logarithm to the exponential way. Here you can write down 1000 equal to 10 to the y. So what is the y value here? What is the y value? It will take the 1000 here. So the y should be 3. If we put 3 here, 10 to the power 3, the answer will be 10 multiplied by 10 multiplied by 10. Answer will be 1000. So that's how by 3. Okay. I think I have completed everything related to my first logarithm session. So we need, in the coming session, we directly move into the properties of the logarithm. Okay. Thank you very much for listening to my channel. Have a nice day.